recording. Okay. So you guys, on this function right here, first of all, you have to determine what type of function it is. It is a quadratic function because it made a shape of a parabola. So we know it's a squared. Okay, if we replace x with x minus 4, it moved it 4 places to the right. 1, 2, 3, 4. And plus 2 moved it up 2 units to right there, the vertex. And so the whole function shifted 4 to the right and 2 up. On this other one, it was an absolute value function. It shifted 2 units to the left. By replacing x with x plus 2, it shifts 2 units to the left. And if you minus 3, it shifts it down 3 units. And so the vertex shifted from 0, 0 to negative 2, negative 3. Okay, any questions on those? The other type of transformation I'll be doing is reflecting. So sometimes it will turn it upside down, right? But all those 3 things will be on there will be 3 problems like this on the test, so you know. Okay? All right. We grade it and turn it in. Okay. I want to find out, first of all, on problem number 1. Turn it off and put it away. Okay. We are recording right now, just so you guys know. So anybody has to watch this later is going to waste a lot of time. All right. Guys, number 8, the challenge problem I gave you. I want to see if anybody's got it. How many of you think you got it? Okay, good. I'm going to ask Amanda and Megan. What did you guys get? Okay, did anybody? Okay, there's another one. I believe either one of these will work. Okay? I believe either one of them will work. Okay? On one of them, this one up here, because if you think about x squared minus 4, and the function x squared minus 4 looks like this. Okay? That's the function x squared minus 4. Well, if all of a sudden you take the absolute value of it, like in the second one right here, it takes anything that was y value was negative and makes it positive. In other words, it's going to take this part below the x-axis and it's going to reflect it up here like that. And that's why you guys get that graph that it just reflects this part over the x-axis. Okay? Whereas on this one up here, if you were to graph y equals negative x squared plus 4, that one is just the same graph except for it's upside down, right? And then it takes all this part that's below the x-axis and it flips it up here. So you get the same graph, right? So that's why you get the graph that looks like this. Okay? It just takes whatever part's below the x-axis and makes it positive. Okay? I like that challenge problem. Good job on getting it, you guys that got it. Okay, number 7. Is that the one on the back? Okay. Number 7 on the back side. By the way, that last problem was number 8. Okay, number 7 on the back side is what type of function, first of all, you guys? Rational, or what do we call it up here? Reciprocal. Okay, it's y equals 1 over x, which is the reciprocal function. Okay, y equals 1 over x, which is the reciprocal function. And all we have to do is move it. Now, you guys keep in mind that the reciprocal function looks like this. And the center focal point is right at 0, 0. So what you want to look at on that problem is where is now the focal point? Look at it. Which way did it shift? Okay, did it look like it went 4 left? And then how much down? I actually think it only went 1 down. But you guys, if you're within 1 on the test of shifting it, I'll give it to you because it's kind of hard to tell. But you need to be within 1 for it to get the whole credit. Okay? But it looks like to me it shifted to the left 4. and 2, and it down 1. So all we do to get it to move to the left is we replace x with what? To move left, we replace x with x plus 4. So the x that was on the bottom now is x plus 4. To get it to move down 1, what do? We minus 1 from the whole function. Make sure you don't put the minus 1 in the denominator. Do you understand that? Does that help out? Okay, so that's how it goes down. All right, is there another question on there you'd like to ask? Those are probably the two hardest ones on there. Most of them you could check on your calculator. Okay, we're going to turn that in right now. Here we go. If you wanted to move this function right here, you guys, f of x equals, let's see. Let's go the absolute value of x. If you wanted to move this function 4 units left and 5 units down, okay, what would be the new equation? What would be the new equation? Write it on your board. All right, you guys, most of you had it right. Some of you guys just didn't put an f of x or y equals in front of it. It doesn't matter which one, but since I had an f of x up there, you should use an f of x. And to move 4 units left, what am I going to replace x with? X plus 4. And what am I going to do to move it down? Minus 5, and there is your answer for that one. Any questions on how to do that? Okay, next question. Here is the function, f of x equals x cubed. I want to move it, let's go, 6 units right, 2 units up, and reflect it over x-axis. Okay? Reflect it over the x-axis. Brandon, you gotta, Brandon stayed up late trick-or-treating last night, and he's having a hard time staying awake right now. Oh. Okay, hey, you guys, this one, once again, is an f of x. Okay, that's f of x. And we're going to reflect over the x-axis as a negative. Although, in this case, since a cubic function has symmetry with the origin, you can actually reflect it over the y-axis and it will look the same way. Okay, but x, 6 units to the right, so x minus 6 cubed, x minus 6 will move it to the right, and plus 2 will move it up. Any questions there? Okay? And negative reflected it. Okay. Next problem. Are we on problem number 4, or am I just off? Okay, that's what I thought. Okay, I want to know if this function is continuous or not. I want to know if that function is continuous. And I want to know why. You say what you're saying, okay? Okay, the answer to this is yes. You guys, by the way, what kind of function is this? It's not rational, is it? It's not rational because there's no x in the denominator. It is a cubic function. A cubic function is going to look like that, which means you could trace this without ever lifting your pencil. And there's no asymptotes to break it up. There's no holes in the graph. Okay, you can trace the entire thing without lifting your pencil, so that this one is continuous. Okay, next problem. Is this one continuous? All right. Details, man. You can't be slowed down by details. All right. Okay. Is this function continuous? Be able to explain why or why not? The answer is no. Okay? Because this one's going to have an asymptote. This one's going to have an asymptote right there. Okay, at 2. You'd have to trace this one. This one, you'd have to lift your pencil. You'd have to draw one part and then the other part. So this one can't be traced continuously, so therefore it is not continuous. Tasha? Yeah. But you guys, listen. You will have to state your reason. You'll have to state your reason why, okay? Well, I would say because it's rational, therefore it's going to have an asymptote, which is going to divide it into two functions that you have to trace separately or something like that. Okay? All right. Next question. Okay, here comes probably the two most difficult problems on the test right here, you guys, depending on when you were here and when you weren't. Okay? I want to know all the maximums and mins. Okay, so here we go. Yeah, you'll be able to use the calculator for this. You have to use the calculator for this. Okay? Negative 3x cubed plus 4x plus 8x minus 10. I want you to find all the local maximums and the minimums. Yeah, I meant 4x squared right here. Guys, I meant 4x squared right there. State all the maximums and minimums. So I'm going to turn this on. Okay, you guys, if you put it in the calculator, you put it in as negative 3x cubed plus 4x squared plus 8x minus 10. And I'm going to start graphing it on a standard window, Zoom 6. Oh, I forgot to talk about end behavior yet, but we'll talk about it again in a second. Okay, first of all, guys, this is a cubic function, and I told you with a cubic function, since it's to the third power, the most number of turns it can have is 2, right? Can we see that this thing has 2 turns? Second of all, the end behavior of this one, we know it's going to go up to the left and down the right because it's cubic. Anytime the power is odd, it goes up one way and down the other. And anytime it's negative, it's going to go up to the left and down to the right. So we know we can see there's a maximum. We know there's going to be a minimum down here. Okay? So we're going to have to change our window. How many of you guys changed your window already? Okay. I'm just going to go down to negative 20 on my y min. And I'm also going to change my y scale to 2. And I'm going to graph that. Okay, so now I can see my maximums and my minimums. Have you guys had enough time to do this? Okay, because these are so wordy, I'm just going to have, well, actually, let's do this. All the ones, show me what you have. I want to see what ones have. All ones, hold it up, please. Hi. I just want to compare answers because I don't know what the answer is yet. Okay. I see different, well, I see the same answers. Never mind. You got to hold it up straight. You're not a number 1, please, you guys. Just number 1s. You are number 1. He is not. Okay. No. Okay. All right. Looks like you guys have about the same thing. Okay, watch this. In case you don't know how to do this, you guys, the calc menu is above trace. To access it, you hit second and the trace button. Okay, and we're going to go to minimum or maximum. I'm going to do the minimum first, so I'm going to hit number 3. And it's asking me for a left bound. So on my minimum is the one on the left over here. I need to go over to the left of it. Well, my cursor is now to the left of where the minimum is, so I hit enter, it marks it up there with an arrow. Now it's asking me for a right bound. I go to the right, hit enter, it marks it with another arrow. These arrows are kind of covered up by the graphs. Now it's asking me for a guess. I go back close to where the vertex is, or the minimum, and I get the minimum is going to be at -0.6, right? Because if you round to the nearest hundredth, it's going to be -0.6 because the 7 rounds the 9 up. Okay, comma, -12.71. Any questions on that one? See how close you were. Okay, my maximum, I hit second and the trace button. I go to number 4. I need to get a left bound. So I mark that. Now it's asking me for a right bound. So I mark that. And now it's asking me for a guess. I get close. And I am going to have my min at 1.49, comma, 0.88. That's if we're rounding to the nearest hundredth. Okay, that is the max. I'm sorry. That is the max. Okay, any questions on how to find this? Okay, good question. Now, next question, you guys. Are these relative or absolute? Okay, they're actually relative. Okay, because absolute is the highest point on the graph. If you look at this maximum right here, is that the highest point on the graph? No, because this graph goes up forever. But it's a high point in that local area, right? And this minimum is not the lowest point on the graph, but it's the lowest point in that area. And so those are relative max and min. Okay, now, the next question, you guys. I'm not going to go to a new slide because we're going to do it on this one right here. I want you to tell me the intervals on which this is increasing and decreasing. The intervals on which it's increasing and decreasing. This is one of the tougher questions on the test. It's not that tough. It's just that for some reason you guys don't remember them. Interval is, remember when we talk about an interval, we're talking about x numbers. Increasing and decreasing is describing what the y value is doing. Okay, so I want to know the x intervals on which this function is increasing or decreasing. I'm going to give you a second to think about it. So on this one right here, okay, you will notice this function, as you move from negative infinity, from the left, what is the y values doing? What are they doing? They're decreasing. So we would say from negative infinity to what? When does it quit decreasing? Negative 0.6. When your x value becomes negative 0.6, it stops decreasing, right? About 3 weeks ago. Okay, so that's when it's decreasing. Now, what does it start doing after that? It starts to increase. The y values start going up from where to where? From what x number to what x number? To 1.49. It's increasing, right? Okay, so as you go from negative 0.6 to positive 1.49 along the x, the y values are going up. Okay, what's it doing after that? From where to where? Okay, and then it's decreasing from 1.49 to infinity. Notice that these are x values, not y values. I always get students who put the y value of the of the thing in there. It's from negative infinity to positive infinity. We're looking to see where it's increasing and decreasing. Left to right. So as you go left to right, this function is decreasing at first, right? So it's from negative infinity until you get to x value negative 0.6, it's decreasing. And then from negative 0.6 to 1.49, it is increasing because it's going up. And then from 1.49 to forever to the right, the y values are going down. Do we understand that? Okay, that's how you tell if a function's increasing or decreasing. Okay, I would get with Callie because she understands. And she's a good friend of yours in case you're just wondering. She can help you out. Or you can watch this video again and see if you can understand it the second time. It's exciting in some parts. Okay. All right. Okay, here we go. Next one. Guys, end behavior. Okay. End behavior. How many of you guys remember what end behavior is? Okay, what is it? There you go. Okay, I want to know what this function is doing at the end. I want to know what this function is doing at the end. All right, let's talk about this, you guys. If you remember right, all we have to look at to find end behavior is the highest degree term. What's the highest degree term in this one? It's the negative 3x squared. Now, you have to look at two things on that. You have to look at the power, which is 2. And what you want to know is it even or odd? It's even, okay? If it's even, they either both go up or they both go down, right? If it's odd, one goes up, one goes down. It can go either direction depending on what? The coefficient. Now, so the second thing you look at is the coefficient. Okay? If the coefficient is negative with an even power, they both go down. If it's positive, they both go up. Okay? If it's an odd power and it's negative, it will go up to the left and down to the right. But if it would have been an odd power there and a positive number there, it would go this way, up to the right, down, left. So what we're saying, you guys, is this one's a parabola. It's going like this. It's an upside-down parabola, right? It's opening down. So we're saying as x approaches negative infinity, that means as x goes to the left, that's what negative infinity means. As x goes to negative infinity, as x goes to the left, y is doing what? Y is going down. So we would say y is approaching negative infinity. Okay? And then the next one, as x approaches positive infinity, that means as x goes to the right, what is y doing? Y is also approaching negative infinity again. It's going down. Does that make sense? You guys remember that? Or you can say, you know what? You really should be able to know how to read that because this is what you need to know to do calculus. But in the past, all I've told the students is it's going down left and right. You could write that. It's going down to the left and to the right. I'm trying to, you know what? I might give extra credit if you write it like this. Write it the other way too, right? It's going down to the left and right. Because in case you mess up on this on accident, if you say it's going down left and right, I like that. So say it like that, okay? All right, and then do this. I'll give you extra credit. All right, and you've got to remind me because I might forget. Okay, next problem. Here we go. End behavior again. End behavior again, you guys. I want to know the end behavior. End behavior. Okay? So really, I wrote this big long equation, but you only care about one of those terms, right? Remember that. Hi. Yeah. Who? Mitch? He's in my class B days last period, not today. Today's A day. Yeah. Um, yeah. Wait, let me think about this. Okay. Okay, let's write this and you guys just make so we can go. We're looking at that right there, right? It's an odd power. What does that mean? It's either going up to the left and down to the right. I mean, up to the left, down to the right, or the top one, up to the right and down to the left. Which one is it doing? Yeah, because it's negative. You guys have got to remember, a positive one generally goes like this, like a cubic function, like this top one. Goes up to the right and down to the left. Well, this one right here is a -5, so it's going to go up to the left and down to the right. So it's doing this one right here. Yeah, you could just put it in the first term of your calculator and see. Did you guys hear what Sydney said? If you wanted to put it in your calculator and check it out, I just put the first term, the highest degree term, not the first term, because I might put the terms out of order on the test, right? The highest degree term. So you guys, this one, you would say as x approaches negative infinity. That means as it goes to the left, y approaches positive infinity, goes up. And as x approaches positive infinity, as it goes to the right, y approaches negative infinity. As y goes to the right, as x goes to the right, y is going down, right? Okay? And if you don't get it, you can go watch this exciting video again. Huh? I am recording right now. Okay. All right, here we go. Next problem. This point is 2, -9. This point right here is 7, -7. And this point right here is 2 or 8, -2. I'm going to connect those 3 points with this graph right here. And I want you guys on your whiteboards to draw the inverse of that graph. Draw the inverse of that graph. You guys, most of you showed me it. All you have to do is switch the x and y, you guys, right? To find the inverse. So if I switch to -9, I get -9, 2. And instead of 7, -7, I do -7, 7. And instead of 8, -2, I do -2, 8. And remember that this is always a reflection over the line y equals x. Any questions on that? Could you do one like that on the test? There's one like it on the test. Okay, next problem. Find the inverse. Find the inverse of that function. You guys, to find the inverse, you switch x and y, right? So, first of all, I write f of x as y. and then I switch them. X equals negative 3y minus 6. And now I have to solve for y. To solve for y, I'm going to add 6 to both sides. And I get x plus 6 equals negative 3y. And then I divide by negative 3. And those are going to cancel out, and I'm going to get y equals x plus 6 over negative 3. You can leave it like that, or you can divide negative 3 into both of them and get negative 1/3 x minus 2, like that. The only thing I'd like you to do different at the end is to write it in inverse notation using the f inverse of x symbol, and write negative 1/3 x minus 2, or the other one, x plus 6 divided by negative 3. And you can write it like that. Say that again? Well, I would like you to do that. I might take a point off. You guys, I'll probably take a point off if you don't do the notation symbol. Okay, what? Yeah. Well. Well, it'd be by negative 3. Yeah. Yeah, that's fine. Yeah, you guys, you can use this one or this one. Just use the notation with it. Okay? All right. Are we ready for the next one? Okay. I want you to find any asymptotes that this function has. Find asymptotes. Remember, you guys, I gave you that paper that tells you how to find asymptotes. I would write that on your 3x5 card, by the way. Okay, find the asymptotes of that function. Okay, you guys, to determine vertical asymptotes, you set the denominator equal to 0. Because wherever the denominator is undefined, or whatever makes it 0, makes it undefined, there's going to be an asymptote. So if I subtract 4 and divide by 2, one of my vertical asymptote is at negative 2. Got that? Okay. Now, that's how you find vertical asymptotes. To find horizontal or oblique asymptotes, you check the what? The power of you check the exponent of the numerator and the exponent of the denominator, the highest degree terms, right? If they're equal, what does it say? You divide the two coefficients, right? So y equals 4 over 2, which is 2. So y equals 2 is your horizontal asymptote. There's going to be one slant asymptote, and I'm going to do one right now. Okay? You guys ready? Actually, there are no slant asymptotes on here. I shouldn't tell you that. There are not any. Okay. All right. You guys, would you like to practice any more of those? Let's just do one. We're going to do one. Okay, everybody close your eyes. Don't look. You can look now, but I forgot to hit Zoom 6 for a standard window. You'll want to remember on your test to go to a standard window to view these. Okay? Find the equation of that function. By the way, I'm not going to do any vertical stretches. I'm not going to do any vertical stretches or shrinks. So in other words, I'm not going to multiply it by anything. The three types of transformations I'll be doing is horizontal shifts, vertical shifts, and reflections. Okay, on this one right here, if you'll notice, it looks like it's, first of all, what kind of function is it? Cubic. So it's an x cubed. It looks like it shifted to the right. 1, 2, 3, 4, 5, or 6, somewhere around in there, right? It might be 5. I think most of you guys put 6 now that I think about it. You might be right. I think it might be 5. And it looks like it moved up 2 units, right? So, yeah, I did put in 5. So the negative flips it over too, right? So it's going up to the left and down the right. It changes its end behavior. X minus 5 shifts 5 units to the right. Plus 2 moves it up 2 units. Yeah. Yeah. You got to count from... You got to count right there. I thought it was at 6 because most of these guys had it 6, and so I was assuming that was. Okay. Hey, you guys, don't stand up yet. Everybody sit down. I want to talk to you for a second. While I'm recording this for just a second, so in case someone's listening that was not here. All right. First of all, okay, that's what I'm going to talk about. The test is Monday. Does everybody understand that? Am I giving retakes? No retakes. Do I expect you to be prepared for it? Yes. Can you prepare a 3x5 card? Okay. Can you use your notes to study from? But not to take the test? Okay. And can you watch these videos? I hope to get them to my website so you can watch them. Okay, put everything away.